Okay, now our next topic is the indirect utility function and the Roy's identity. We will study both these topics, and then after this, we'll study the Slutsky equation. So what is an indirect utility function? It is derived from the consumer problem, where we want to maximize the utility subject to a budget constraint. That is, we will start it from maximizing the utility function of a consumer, where our objective is to maximize the utility, that is max u. Okay, then we have utility is derived from x1 x2 till xn. Okay, so the utility to be maximized by consuming the goods x1 x2 till xn, there are n number of goods. Okay, and this utility maximization is subject to the budget constraint, that is the consumer has to pay money income in order to pay for the prices of the goods. So therefore, there will be I number of goods. So therefore, the budget constraint is summation pi xi, and this should be less than equal to the total money income that the consumer less than or equal to the total money income that the consumer has. This is the budget of the consumer. So we know that as we have been studying it throughout, the values of x1, x2, x3, they can be, these x values can be greater than or equal to 0. That is, there is a non-negativity restriction of the consumption of the goods. Optimal xi is given as, now if we want to know what is optimal xi, then it is given as xi star. We use the star symbol for the optimal values in our microeconomic analysis. So xi star is equal to bi, the demand for the goods, given the prices, that is P1, P2. Okay. Again, we know that there are n number of goods. We have x1, x2 till xn. So therefore, their prices are P1, P2 till Pn. Okay. And of course, yes, there's one more thing that we have to add over here is that given the income level of the consumer. Why? Because now we have added the budget constraint also into this equation. So we have to maximize utility given the budget constraint. Therefore, the optimal xi will be given as P1, it is the function of prices and the income of the consumer. So now maximized, therefore, if we write the simple form of it, we get xi star is equal to, simple form is xi star is equal to di. Okay, bracket p comma n. Okay, so this is the general form of the optimized, or you can say the optimal bundle that the consumer will choose to consume. So now the maximized value of u, x1, x2 till xn is equal to, now when we are, earlier we took the utility function that where the goods were consumed by the consumer. Now the optimized, or we can say that the maximized value of utility will be u x1 star, that is the x1 good that he's consuming is the optimized value, x2 star, the good x2 he or she is consuming is the optimal value, and so on, and it will go to xn star. Okay. So now let's move ahead. It will be a function of pi and n. So therefore, this is the function of pi, comma n. You can write it in bracket, you can write it simply like this, but you should know that this is function of pi and n. Therefore, in order to further simplifying the equation or rewriting it again, what we get over here is we get u x1 star, okay, comma x2 star till xn star. Okay. Now this is equal to u Okay, D1. You have to write the demand function for every bundle of goods that the consumer is consuming, given the price and the money income of the consumer. U D 1 into PM. Okay. Then we have U. Okay, U is written over here. Then we have D2 PM. And in the end, what we will have is DN into PM. Okay. DN into PM. That is the prices of the goods and of course the money income of the consumer. Now the bracket closes over here. So what comes next is again simplify this particular equation, the one that we wrote now. Now by simplifying this particular equation, what will we get over here is we will get U star PM. That is U star, okay, U star PM. P and N. Now this is equation number 1. We'll proceed now by taking into consideration basically this function that we have now got. Okay. Now this U star, let's study the interpretations. Okay. Now U star is known as indirect utility function. Our main topic is about indirect utility function, and this U star is the indirect utility function. Okay. Like this, okay, or let me, okay, so it's fine. U star is known as indirect utility function. Why? Because it is indirectly, it indirectly depends on the prices and money income. It indirectly depends upon the prices and money income via the maximization process, in contrast to the utility function, which directly depends on the which directly depends upon the XIs. So we can use U star to investigate the effects of changes in the price and money income on the consumer's utility. Okay, let me do one more thing. Let me just make it more clearer to you. Now, okay, this U star is known as indirect utility function. Why? Because it is indirectly related to the prices and the money income. As you can see over here, it is indirectly related to the price and money income for each demand function via the maximization process, which is in contrast to the utility function U x1, x2 till xn, where utility depends directly on xi. So we can use this U star, we can use U star to investigate the effects of changes in the price and money income on the consumer's utility. Now what we want to do, we want to investigate the effects of changes in price, a change in the value of T, and of course, a change in the money income, okay, on the consumer's utility. Now from the interpretation, Lagrangian multiplier, the effect of increase in the money income on the maximized utility is, as previously we studied that the okay. Now the effect of change in Pi on U star can be found as the version of envelope theorem. We will differentiate U star with reference to Pi. Then what will we get is, we will get curly U star, curly U star, okay, curly U star divided by curly Pi. is equal to curly UK. We have studied this before also in the expenditure function, into curly summation UK into curly X K star with reference to P prices PI. This whole is now the version of envelope theorem, which will give us the value of lambda summation PK curly XI star curly XI star with reference to curly PI. So this is what we get after finding the change in the PI on U star as a version of the envelope theorem. Now again, we know we have this budget constraint also in our equation. And therefore, for that purpose, what we do is that the budget constraint, or let's simply write it as BC, the budget constraint will be written as now D over dPi differentiating the function with reference to Pi given the summation Pk xk star. Okay. Now what will this yield? This will yield dm upon dPi. And therefore, dm upon dPi is equal to 0. dm over dPi is equal to 0. So therefore, we can say that summation Pk xk star divided by curly Pi. Okay, let me rewrite it again over here so that it's easy for you to understand it further. Therefore, we can say that summation, okay, Pk, summation Pk curly xk star divided by curly Pi plus xi star. Okay, this is equal to 0, right? Or with now what we will do is that we will shift this xi to the xi star to the left hand side. That is, therefore we get minus xi star is equal to summation Pk curly xk star divided by curly Pi curly xk star divided by curly Pi. Okay, now this is, let us take this to be our equation number 4. So therefore we have got a value of xi star over here. Now therefore substituting this equation number 4 value in our equation, that is the one that we derived over here. Okay, let me go to that equation. Where is curly ui star upon? Yes, over here, I've got it. So what we do is that the value of equation 4 that we derive over there in the end. Now let us substitute this into, now let us substitute this value, that is summation Pk. Okay, let me just, yeah, now it's more better. Now substitute the value of xi star from here, from equation number 4 into this equation, and let it be named as equation number 3. By doing so, what will we get is that we will get a Roy's identity. I'll write it over here so that it becomes easier for us to see the. Okay, we will substitute the value of xi star from here into this particular equation, and therefore we will get the Roy's identity, which will be as follows: curly u star divided by curly pi. Okay, this is equal to now minus lambda xi star is equal to minus curly u star divided by curly m. Okay, multiply by xi star. That is what we did over here, is that we have taken this value of minus, here we have a minus sign as well. We have taken this value of minus xi star and substituted it into this particular equation. Therefore, what we got over here was, as this is curly u star upon curly pi. So therefore, we have multiplied this lambda, the one that we have over here, and then summation pk curly xi star, we have it over here. Okay, clear? So therefore, what we did, this whole is now, okay, let me select a pen from here. Let me take a black pen. Now this pk curly xi star is equal to x minus xi star. Therefore, we have written minus xi star over here. This whole value, in fact, summation pk curly xi star divided by curly pi. This whole is equal to minus xi star. Therefore, instead of writing the whole value, we only substituted minus xi star over here. By further solving it, we get minus curly u star upon curly m into xi star. That is what we did over here, is that the value of lambda has been taken from here. Okay, let me just go. Now, the value of lambda has been taken from here. That is, the value of lambda is curly u star upon curly m, and therefore instead of this lambda, we have substituted the value curly u star upon curly m, and it has been multiplied by xi minus xi star. The negative sign is written over here. Okay, minus xi star, which is equal to, okay, which is equal to summation pk curly xk divided by curly pi from here. All these values are taken from different equation and then substituted in this equation number 3, and therefore this has given rise to another identity, which is known as Roy's identity, that is, which is minus curly u star upon curly m into xi star. So therefore we will name this as equation number 4. Okay, let this be equation number 4. So right hand side of the equation shows that this is the right hand side of the equation. I'm talking about this equation now. Okay, this is RHS. Now right hand side of the equation shows that an increase in the PI is reduction in the purchasing power of consumers' money income. When the prices increases, it means that the purchasing power of the consumer decreases, because at the given money level, money income, he can now purchase fewer goods, and therefore this is negative sign is showing the same thing to us. Okay, as per Shepard's lemma, to the first order, the purchasing power of consumer falls at the rate minus xi star. If we are going to interpret this particular value as according to Shepard's lemma, then what will happen is that the purchasing power of consumer will fall at the rate minus xi star as the PI varies. When the value of PI varies, the purchasing power of consumer will fall at the rate of minus xi star. Lambda is the marginal utility of income over here. Over here, it will not be regarded as marginal cost, rather it is the marginal utility of income. Okay, the product of lambda and xi star, the one that was written over here. Okay, it's the product of lambda and xi star is the rate at which the utility varies with money income multiplied by the rate at which money income varies with pi. Okay, what is product of lambda and xi star? The rate at which the utility will change when the money income multiplied with the rate at which money income varies with pi. Therefore, this product yields the rate of change of utility with respect to pi. The satisfaction level, the rate of change in the satisfaction level is studied through this product with respect to the change in the pi. As lambda is greater than 0, therefore, increase in the price of a good a consumer buys reduces her maximized utility. What happens over here is that we know that the value of lambda is greater than 0. So therefore, when we know that value of lambda is greater than 0, it means that the increase in the price of a good a consumer buys will reduce her maximized utility or a standard of living to a greater extent. Therefore, the larger the quantity of it she will buy. In the indirect utility, utility depends on the price income situation the consumer faces. Indirect utility will also monotonically increase with the M. Indirect utility function will monotonically increase with M. Now, where do we have indirect utility function? This is indirect utility function. What is this showing? It is showing us that there is a monotonic increase with money income. Let me just take it. I'm talking about this equation now. So from indirect utility function, we can get expenditure function. Where we have the expenditure function from the indirect utility function, it will be equal to U is equal to U star into PM. This is the indirect utility function. Okay. Now what will we do? We can find out the expenditure function from this indirect utility function, that is capital M is equal to small m into P comma U. Okay. The two functions are dual to each other and they contain some information. Okay, these two functions are dual to each other and they contain some information. And the duality can give a better derivation of Roy's identity. This duality will give a better identification of Roy's identity. Therefore, setting M is equal to M into PU. We can rewrite the indirect utility as now we can rewrite the indirect utility as U is equal to now U star. Okay. This U, I'm talking about this equation now. And by substituting this one into it, U is equal to U star. And then what we get over here is P. And in place of this capital M, what will we write? We will write M P U. So therefore, we have incorporated the expenditure function in the indirect utility function. Now we differentiate with reference to Pi. Then what we do is that we will differentiate with reference to Pi. One thing should be known over here that in the expenditure function and the indirect utility function, we are differentiating with reference to Pi. Therefore, if we differentiate it with reference to Pi by allowing M to vary, this small m to vary, in a way as to hold U constant, what we will get? We will get 0 is equal to curly U star. Okay. Curly U star divided by curly Pi. Okay. Plus curly U star divided by curly M multiplied by curly M for curly Pi. It gives the Roy's identity by using the Shepherd's lemma. This is a very important equation. Okay, this is giving us the Roy's identity by using the Shepherd's lemma. Okay. So therefore, after this, we will move towards the important property of indirect utility function. Okay, now let's move to our property of indirect utility function. Indirect utility is ordinal, it is not cardinal. Therefore, it is quasi-convex in the prices and income. When we talk about the indirect utility function, it is quasi-convex in the prices and income both. Previously, we studied the expenditure function, and in its property, we studied the concavity in prices, okay? Now over here, the important point is that it is quasi-convex in the prices and income. Let me write it over here for you people. Now, for this property, that is the quasi-convexity of the indirect utility function in prices and income, we need to draw two figures. This is the first one. Let us name this as figure A. And then we have the second figure. Let it be named as figure B. Okay. So therefore, what we have over here is we have the prices of the product P2 to be equal to P2 naught, okay? And over here the price is P1 naught. And then what happens over here is that we have the price P1 naught over here, okay? And then the next thing over here on the x-axis is the money income, which is equal to M naught over here. Therefore, on x-axis and y-axis over here, we take the prices of both goods, price of good 2, price of good 1 in the panel A, whereas in the second panel, we have the money income on x-axis and the prices on the y-axis, price of good 1. Now, the quasi-convexity shows that we will have this convexity is basically described by the property which we will study. A function is quasi-convex if at any given point in its convex domain, okay? In its convex domain, the worst set of that point, that is the set of points giving the same or lower values of function, is convex. Suppose we have two goods, and now suppose we have two goods, and the indirect utility function is, now we know how to write the indirect utility function. It is U star P1, P2, and N, okay? These are the two goods, and the indirect utility function is P1, P2, and N. Okay, now in figure A, what happens over here is that P naught, the given prices are P naught is equal to P1 naught and P2 naught. Comma P2 naught. Which is some arbitrary point. Indifference curve is U naught. This is the indifference curve. Let me be a little bit. Yeah, it's fine now. Now the indifference curve is U naught over here. There's one more thing that I want to explain over here is that is, let me. So now P naught is equal to P1 naught and P2 naught. It is some arbitrary point. In the figure B, the curve should be of this shape, okay? So indifference curve is U naught, that is this one. It is the contour of indirect utility function through that point is convex to the origin, okay? Now this point is convex to the origin. The worst set WP naught, that is WP naught, the worst set is equal to P1, P2, that is given the utility lies northeast of the P naught. In this figure, the next one, that is figure B. Now, what is over here with us is the contour that is U naught. Okay, again, this is also U naught. Contour that is U naught to the point P1 naught and M naught is convex from below. Now this is convex from below because the worst set lies to the northwest of the point. Now here, the worst set lies to the northeast, and here it lies to the northwest of the point. So therefore, we can say that the indirect utility function is quasi-convex in prices and income. So therefore, this is also convex curve. This is also convex curve. Both the curves are convex, but their positions are changed. This is convex to the origin, and this one is not convex to the origin. Therefore, the worst sets are different. For the first figure, the worst set lies to the northeast of P naught. Okay, this lies to the the worst set lies to the northeast of the P naught, and over here the worst set lies to the northwest of the P naught. I hope it is clear. Okay, let me. So therefore, our topic finishes over here. After studying this property, after this topic, we will move towards the Dirichlet equation. It's an important equation. And after that, we'll study very briefly the properties of demand function. That too will be incorporated into the Slutsky equations lecture. Thank you very much. If you have any questions, you can ask me anytime.